Okay. Hello, everyone. Welcome to the 137th MedAI Group Exchange session. Today, we have with us Dr. Sarvesh Soni, who is a research fellow with Dr. Dina Damner-Fushman at the National Library of Medicine. Sarvesh has a PhD in biomedical informatics from University of Texas Health Science Center at Houston, and his research centers on clinical NLP with a focus on question answering methods using electronic health records or EHR data, as well as clinical text generation. He has developed methods and data sets for automatically answering patient-specific questions using structured and unstructured EHR data and exploring clinical semantic parsing, paraphrasing, information retrieval, and machine comprehension. Currently, he's working on automatic generation of progress notes using structured chart data. And today he'll be presenting his work on the same, like developing systems for relieving clinician burden by automatically generating progress notes. So without further ado, let me hand it over to Sarvesh. But before we start, Sarvesh, how would you like to prefer to take questions from the audience? Do you want to people to interrupt you while you're giving the talk, or you want to keep the question answering thing towards the end of the talk?
It's fine to take it on the go. Like, feel free to interrupt me.
Okay.
Yeah,
Awesome. Awesome. Okay. Awesome. With
sure,
that, we can you can go ahead and start. Yeah.
sure. Hey, yeah, thank you, Avisha. First of all, thank you for inviting me to give this talk, and I'm really excited to talk to the MedAI group. So today I'm going to talk about our work on relieving clinician burden by generating progress notes. And I'm also going to talk about another strand of work, which is related to automatically generating patient responses to patient messages. And both of these are tied to relieving the clinician burden. It's a disclaimer that the views are of my own and not of the government. Very brief introduction about me. So I have an undergrad and master's in computer science. Then I went on to do my PhD in biomedical informatics, where the focus of my dissertation was on question answering from electronic health records. And I'm currently a research fellow at the National Library of Medicine, where I focus on natural language processing. Specifically, the two strands of work that I focus on are progress note generation and question answering. So I'm going to talk about some aspects of both the two strands in this talk. So like Avisha mentioned, feel free to raise a hand or stop in between if you have any questions. So what are progress notes? So progress notes are also known as SOAP notes. They are regularly written by clinicians in order to document the care provided to their patients. These notes are used to share care between different providers, and ultimately, this information resides in the electronic health record for record keeping purposes. The acronym SOAP comes from SOAP, the four different broader sections present in a progress note. These correspond to subjective section, which contains patient-reported information, such as the pain that they are feeling or what are the problems that they have in their own perspective, from their own perspective. The second section is objective section, which contains objective information about the patient, such as the lab values, their vitals, signs that we can measure from the patient. The last two sections are called as assessment and plan sections, and these sections incorporate the diagnoses written by clinicians as well as the treatment plans that are assigned to the patients by the clinicians. So, in these two examples on your right, these are progress notes written approximately 1 day apart. So these progress notes are written regularly, like I mentioned. So more often they are written every day to account for what is the process that's been made by the particular patient on a particular treatment, and if it's working, not working, accordingly they go about changing the treatment or order new tests and so on. So in the first progress note, for the specific problem of sepsis. So these assessment and plan sections are usually separated by different problems. So in this case, for the problem of sepsis, the different assessment and plans were that the patient showed response to a particular treatment, and the plan was to continue antibiotics. And next day, the status of the patient changed, and they were able to be weaned off of pressors. And but the plan was still to continue antibiotics. So in this way, for each particular problem, the diagnosis change or the treatment plan changes or not change. So these kinds of information are documented in the progress notes on a daily basis.
Sorry, one quick question.
Sure.
In the progress notes, sorry, it's a bit naive. Where do they write it? Do they write it in like an Epic in the Epic software?
Oh, yeah, these progress notes. Yeah,
Yes.
whatever is the interface provided by the electronic health record system. So some people, I think, Epic provides an interface to write these notes. So they
Okay.
can write it, and I think everyone has a different way of drafting and then entering in the EHR.
So, Sarvesh, I have a follow-up question actually. So
Mhm.
when you say sepsis, that means you are primarily talking about the progress note from inpatient, right?
Yes, these are inpatient notes. Yeah, these are inpatient progress notes.
So not like the outpatients after they were discharged from the hospital. So primarily inpatient notes because they are
Yes,
kind of like linguistically they are very different between inpatient and outpatient.
right. Yeah, these are progress notes. Specifically, when I talk about the specific data set that we use to curate these come from an intensive care unit database. So these are all inpatient data, and these progress notes are roughly written every day by physicians.
So these are another question. So these are the progress note after the sepsis was detected, right?
So progress notes are written
Every
almost
day, yeah. But
every day
the
by
the
like
notes that you are using, they were
yeah
after only a sepsis, or is again random?
yeah. So they start writing it the day they are admitted, right? And then at that point they figure out some potential problems. At that time they may or may not figure that okay, if the patient has sepsis or not. They may also develop sepsis while being admitted. So maybe progress notes 1, 2, and 3 might not have sepsis, but progress note 4 may have
So
a
you
mention
you
of
also
sepsis.
you also are considering those notes which does not have sepsis.
Um, so so when you go from one node to other node,
Right.
so it depends. It is based on the existing information, right? So you may or may not capture that the sepsis was a new problem that was found. That becomes like part of the error that the model was not able to find a new problem in the next node. Uh, Any other question?
We have a few questions from the audience.
Okay.
So the first question is like, what data sets are you using?
Okay. Yeah, I'm going to talk about that when we go forward, like what the data sets that we used. Briefly speaking, at this point, these come from intensive care unit. So these are progress notes that are written when the patients were admitted in an intensive care unit.
Okay.
Yeah.
And then we have, so are these data sets public? That is like a follow-up
They are
question.
accessible to public, but
Okay.
people have to go through a set of training because these contain de-identified information, but they are still sensitive in nature. So they need to go through uh, uh, some credentialed training in order to get access. But they are open to public. So anybody who has completed that training, which is free of cost, they can access the data set.
So a few more questions. How do you structure them into SOPA sections? Are they pre-processed? And
They are
how,
not pre-processed.
okay.
Yeah.
And I guess you will be talking about how you structure them later on, right? SOP into
Uh,
pre-SOP sections.
they're not, but we wrote kind of some rules because these all come from one medical institute. So it was easier to write rules on those notes and just structure and divide it into these different categories. So we didn't use any different fancy model for separating these.
Okay. Are these progress notes in the primary or secondary care? That's another question. I don't know if you can see this. It's in
Primary
the
or secondary.
chat.
I
I don't
can
know.
see that. Yeah,
Yeah.
yeah. These come from different types of ICUs. So they have all. So they have trauma ICU. They have I think the I think MICU, and like they have different kinds of ICUs, and but everything is related to the ICU care, not anything outpatient or things like that.
Okay. And how many nodes do you need?
We will talk about it when we talk about the data set. So
Okay.
yeah,
Okay. Thank you.
yeah. All right. Yeah. Let's take I'll stop after like so these have like three different stops in
Okay.
the presentation. So we can take maybe some questions after I complete like the first part of it,
Yeah.
and then we can take questions, and then I can stop
Okay.
at the second part. Okay.
Okay.
Yeah. All right. So first of all, like why do we need to even automate this generation, right? Because clinicians are already writing it, and there's so much information available in electronic health records that the clinicians are able to make better assessments and write these notes much better, right? But this huge amount of information also leads to information overload and also documentation burden associated with it. So this presents with an opportunity for us to use this available data and to automatically generate the note to assist the clinicians in writing these progress notes. So briefly speaking, if you are provided, for example, the progress note from previous day, and you're provided all the structured chart data that was collected in the last 24 hours, can you automatically generate a progress note? That is the proposed task for this particular talk. And the structured data that we are interested in are such as like central venous pressure. So these are different measurements that are recorded in the electronic health record in the past 24 hours for that patient. So the four different categories that I talked about from the progress note, right? So subjective section is patient reported, and these are best captured from the clinician patient conversations. And there's a huge amount of work in this direction where this section is automatically populated using that data. The objective section is more often copied directly from the charts. Differently, the assessment and plan section requires a careful analysis of the past notes as well as the structured chart information present in the record to draft these notes. So, and in this particular task, we focus on the assessment and plan section. So the dataset comes from a publicly available dataset, which is called as Mimic3. It is a critical care database, and like I mentioned, it is freely available to anyone who completes the training required to access the data. The dataset that we curated from Mimic3 consists of data from over 1,600 patients and contains more than 7,000 annotation instances. So each annotation instance consists of prior note, all the structured chart data in between, and the next progress note that was written for that patient. So the thing that I want to highlight here is the amount of information that's available only in the structured part of the chart, which is close to 1,500 rows. And due to this huge amount of information, it's very difficult to use that whole um, information at once in order to generate the next progress note, especially with the models that we have at the time. So we proposed a framework to automatically generate the next progress note while synthesizing the structured chart data into a more manageable format for the model to use. So we ultimately create a summary of the structured chart data. And how we do that is by, first of all, extracting the chief complaints from the patient's prior note. So we are not using chief complaints that the patients are admitted with, but the ones that can be inferred from the prior note, because those basic chief complaints can change over time. And then based on those chief complaints, we start to summarize the huge amount of structured chart data in an iterative manner. So we first take a first few rows of the structured data, and we ask the model to summarize this information. And then we iteratively refine the summary based on the new structured chart data that the model sees going forward. And at the end of it, you have the chart data summary that you use alongside the prior node in order to generate the next node. We conduct a series of analyses to see how the current models perform on this task of automatically generating the next progress nodes. Uh, for actually understanding the results, let's focus on these few numbers for now. The metrics that we used were Rouge. Rouge is a text-based metric, so uh, it compares the predicted progress node with the actual progress node that's available in the electronic health record and calculates the textual similarity between the two. PERT score is based on the semantic similarity, so it goes about comparing the meaning of the predicted and the actual text that is present. Metcon metric works a little bit differently, and it compares the medical concepts between the prediction and the ground truth text. So if the predicted text mentions some clinical concepts and the ground truth has a set of other clinical concepts, what is the overlap between those concepts? So that this is what that number reflects in terms of the F1 score between those two sets of medical concepts. The four baselines or models that we use is the first one is the prior node. Prior node baseline is basically not generating a new node altogether, merely just returning the prior node as it is. The other three rows in the table correspond to three large language models. The first one is BioMistral, which is a pre-trained version of the Mistral model on PubMed dataset. The second one is a mixture of experts model by Mistral. And the third model is the Llama, the second generation of the Llama model, and we use the 70 billion version of it. Coming back to the numbers, the prior node results that you see in the table, you see that they are the best numbers in the table, but they merely correspond to the highly similar nature of the prior and the next progress nodes that's available in the electronic health record. So, and this is an artifact of the way that these progress nodes are usually written. They are oftentimes copied and then they are edited. So that may be the case why we are seeing higher values for this prior node baseline. But among the other among the other large language models, we see that the biomestral model performed the best despite being the smallest model. And this may be because of the additional biomedical fine-tuning that went into it. So to actually gauge how well these models performed, we conducted a manual analysis on a subset of these nodes. And I want to highlight just this one row that is kind of the main takeaway of the manual evaluation, is that the generated summary played the most important role in the final predicted progress node. So if the relevant information in the progress node was present in the summary, then the models were more often than not able to use that summary in order to include that information in the next progress node. So this created kind of like a bottleneck for generating the next progress nodes. And this concludes like the first part of the talk, where we saw that the progress node generation is an important task, and we curated a dataset called ChartPNG for tackling the task of automatically generating progress nodes. We saw some of the challenges that are involved in progress node generation, and like I mentioned, the summarization of the chart data remains a bottleneck in order to generate the next progress node that is more closer to the actual progress node in the EHR. So yeah, this work was also presented at EMEA last year. And at this point, I can take any questions if you have before moving forward. We have questions?
May I ask a question? How you
Sure.
generate summary reports?
How do I evaluate the summary of a report?
How to generate? Let's see.
Oh, how to generate? Okay.
Paragraph. How you generate summary of the paragraph?
Sure. Yeah. So we generated the summary based on the so we have tabular information of the chart, right? So it's close as on an average we have 1,500 rows of information for each patient. A lot of the rows are repeated, but the data is different, right? So we kind of try to generate a summary of those 1,500 rows using the model, but we cannot feed all those 1,500 rows at once. So we resort to feeding a few rows at once and then feed every n rows in an iterative manner to refine that initial summary. And that's how we arrive at the final summary of the structured chart data.
Do you possibly use GPT for large language model to say summarize this paragraph?
Right. Yeah. So these are the models that. So when we say that the performance by these models, so the biomistral, mixtral, and llama. So these were the models that were used for both summary and the next node generation.
I did not fully understand the prior node. So you compare the next node with the current node. You use a measurement compare between the current node and the next node, or what's the prior node mean?
Prior node baseline means that instead of generating the next node, you are just returning the prior node as it is. You are not really generating. You're not really predicting a new node. You are outputting the input node as it is. So as to the model is just cheating and not really generating anything.
Or you output the current node.
Yeah.
That should be 100. That's right.
But we are not comparing with the current node. We are comparing with the next node.
Or previous one. You try to use the next one, but you compare with the previous one.
We compare with the next node.
Oh, I still not fully get the idea here. Let's see your current node is here. Okay. You try to predict next one. This is t plus 1.
Sure.
So you compare with t minus 1?
No. We compare with t plus 1.
You're not generating the t plus 1.
Yeah. A manual evaluation as well, because merely returning the previous node achieves better results, but that does not mean that you are actually getting better results.
How you compute the BERT score?
It's based on embeddings. So it calculates the embedding of the actual node and the predicted node and compares the similarity between the two embeddings.
It's one vector.
Yeah,
there will be one embedding for the whole paragraph.
Yeah.
Okay.
I mean, it can be calculated in different ways, but yeah, we use the standard version of it.
Hi, Sarvesh. I was wondering, so I understand like feeding the prior node, you have to summarize it, right?
Yeah.
So how about generation, right? So the assumption is that the model would also be generating a kind of a summarized version of the next node, or what do you think about it? Like you can expect a realistic length node from the model, or you should just expect a summarized node?
We expect a real next node from the model. So like
Okay.
generate the proper next node. Yeah.
Okay. Okay. So you're
Yeah.
not assuming any.
This was like an initial set of experiments where the main part was creating the data set and then establishing baselines on it to
Baselines.
see how you can do it with off-the-shelf models. So like, can you just generate the nodes as it is with providing the information?
Thank you.
And we figured that thank you. No worries.
And the board can give you a summary score in some sense for one paragraph. GPT for Llama can do the same thing.
Yeah, we are using Llama and Mistral based models.
So you can get the board embedding from Llama directly.
No.
No.
So the models are used to generate the nodes, but these metrics are evaluated using different models. The BERT score is evaluated using BERT model.
How you get something from the Llama, let's see the computed board score.
I think we can refer to the citations probably. I think BERT score has like a citation somewhere, right?
We have a citation in the paper to
So-
the BERT
Okay.
to the BERT
Okay.
score paper.
Yeah, I think we can just move that discussion to that. Probably the author can share the citation after the talk, and we can just share it with the audience.
Sure. Yeah. Of course. Yeah.
Thank you.
Yeah. No worries. So, like as we saw, that summarization was one of the problems because you have huge amount of information. So we went about improving on that aspect, so like how we can improve on that, the processing of huge amount of chart information, right? So we have been using the locally run models so far, which are based on Mistral and Llama, and they offer many advantages, like they can run entirely on premise. They provide a more transparent, adaptable, and secure way. However, they have their own disadvantages, such as the limited input context size, and also their reasoning capabilities are somewhat limited. On the other hand, you have web-based models. You might have heard of ChatGPT and the Anthropic's Claude. They possess more stronger reasoning capabilities as compared to locally run models, but they are available exclusively via web APIs. And there are several concerns, especially in the medical domain, about sending sensitive patient information to the servers. So we explored a mechanism where we can take advantage of both the worlds. And if we can use the stronger reasoning capabilities from the web-based models, but still enjoy the transparency and the running on-premise uh, things from the locally run models. So we proposed a benefit, which very briefly, what it does is that use the web-based model to help in summarizing the structured chart data without sending the specific patient information to the online servers. And then we use the locally run models to use this distilled information in order to generate the next progress node. So this is the proposed framework, and you can go one by one to get an idea of the framework. So you have as input, you have the prior node and you have structured chart data. From the prior node, we can parse the problems. So in the prior node, for example, you have problem of anemia, you have problem of renal failure, and so on. And then from the structured chart data, you can parse out all the unique labels that are available for that patient, right? So you have, for example, edema, hematocrit, hemoglobin, and so on. And then you use the web-based model. In our case, we use the Claude model from Anthropic, and you only pass the problem name, not the associated content from the progress note, but only the problem name. In this case, it is anemia. And you pass this unique set of labels for the patient. Again, this does not contain the specific values of hemoglobin or edema amount and so on. And you're passing all this generic information to the model, and you're asking the model to filter these list of labels based on the problem, the specific problem on the patient. And then you get back a filtered list of problems that you can use for this patient. We use this filtered list to create a summary by using a set of heuristic rules. So let's say you got that activity tolerance is one of the important measures in case of anemia. And you still have many rows for activity tolerance. So you can, in this case, you had more than eight rows in the data. So you can write rules to create kind of a summary statistic and condense those 8 different rows into a line that says activity tolerance. The same level of activity tolerance was reported 8 times from this date to this date, and it was measured as tolerated well, right? So in this way, you curate much more condensed version of chart data summary. And then we use this chart data summary along with the problem name as well as the specific content for that problem from the prior note. And we use it with the locally run models. In our case, we experimented with Mistral and Llama, and we generate the next progress note for that particular problem. So at this point, we have the next predicted note for the specific problem of anemia. And then we repeat this for all the problems that is present in the prior notes. And at the end of it, you can combine the different generated progress notes snippets for all the problems. So for example, for anemia, for renal failure, and so on. And you curate this finally predicted next node. So this is a brief explanation of the framework that we proposed that can still utilize the web-based models without sending these sensitive information to their servers. We conducted a similar kinds of analysis using by the incorporation of this framework, and we again focus on these 3 specific columns for these 3 specific metrics, which is Rouge, BERT score, and Metcon. What we saw that with the inclusion of this knowledge framework, all the models improved their performance in terms of Metcon metrics. So they were able to include the more relevant clinical concepts in their predicted progress nodes when they were compared to the ground truth nodes. And all the larger models improved on their metrics across all the, across all the different metrics. So in this case, the Mistral 56 billion and Llama 70 billion model, both the models improved by at least some number on Rouge, BERT score, and Metcon. Of note, the jump was more than 4 points on Rouge and as much as 7 points in terms of Metcon metric for the Mistral model. We also conducted a similar qualitative analysis, and this is a summarized version of the qualitative analysis where in terms of the relevant information, whether the note was able to encapsulate the relevant information that the change that happened between the 2 progress notes. A good example from the data was that the gold mentioned for the problem of tachycardia, it was likely due to pain and fluid status, while the prediction mentioned that it is likely related to pain and possible dehydration, which is a good example. But there were also instances where the model was not able to capture important information, such as the gold note mentioning no evidence for DVT, but the predicted note could not capture anything about DVT because the no evidence for DVT is an important characteristic that should have been noted in the predicted note. There was also a case of, you can call it hallucination or an incorrect generation, where the actual note mentioned that the septic shock is now resolved and the patient is now able to be weaned off of pressors, but the predicted note still recommended increasing the dose of the vasopressor support. So there's still cases of model generating incorrect information. So from this extension of our work, we found that we can still utilize the locally run models by utilizing the capabilities of larger web-based models in a different way without sending the sensitive patient information to the online servers. And in this way, we also saw improvements in terms of generating the progress notes. This work was presented in a private NLP workshop at ACL last year. So yeah, at this point, if you have additional questions, I can take. Otherwise, we can move forward to the last part.
Sarvesh, I
Yeah,
just
so-
have one. Yeah, sorry, I want to
Sure.
go ahead.
No, and Dr. Banerjee, just go ahead. Yeah.
Yeah, I just have one quick question, Sarvesh. So I still don't understand that why you were evaluating the string overlap matrix, because I think the more important thing is that if we miss some information or not in the growing progress note. So I think it would be more interesting to see any kind of like retrieval based matrix or some kind of like missingness matrix, because string matching matrix, like all the progress note has kind of like similar template. So if you calculate even like with the prior progress note, it should be pretty high.
Yeah. So yeah, it was tricky to decide like which specific metrics to include. Like the best way to do is to go about doing manual evaluation, but it is
Yeah,
very
exactly.
costly. Yeah.
So even if you do
So
that
we
on a
have to,
subset, probably it would still be okay that at least
right.
on 100 to 100 samples that you manually annotate and see that what is the important
Yeah.
information are preserved or not.
Yeah. So this is what the qualitative results were on, like using a handful of notes, and then evaluating those notes for the information that the model might have missed or might not have missed.
Okay.
I think
Because
we just have like
one
quick
question. Yeah. Sorry, go ahead, Kumar.
What triggers a new progress note generation, a new data coming in?
Oh, yeah, that's interesting. So what triggers it? Basically, in our case, we use the time point at which the actual next note was written. We generate the next note at that particular time point. So we make the model aware that this is the time right now, and you can use this. All this information is provided to you, and the model can do this relative judgments on the last 24 hours worth of data based on that time point.
Okay, thank you very much. I think we can move ahead.
Okay.
I have just one question. How do you planning to get rid of this bad things? You mentioned something, no evidence found, DBT dot.
Mm-hmm.
So is there a plan to resolve these issues? No evidence for DBT. The model could not able to capture that, right?
Yeah.
So is the how can you do you have any plan to resolve this?
Yeah. So we have some. Yeah. So I think it's a right point to move to the slide for like that concludes this portion of the talk, which is that the future work section that
Okay, no problem.
so we want to incorporate other types of data, so that it might be the case that we are missing information that is not available in structured data. For example, we did not include radiology reports, right? So, but that may serve as very important context when you are writing the next progress note. So that is one point. The other point is using more complex types of prompt engineering. So what we used was vanilla prompt engineering. We ask a question, we prompt the model, and then we grasp the output. But we can also explore other sophisticated types of mechanisms such as chain of thought reasoning. And ultimately, another ongoing thought is to fine tune the models on the data set that we have. Since we have a large enough data set, we can see if a tuned model can perform better on this particular data set or not. Because until now, we have been using the models off the shelf. We are not really tuning it for this task.
Okay, thank you, Sarvesh.
Yeah.
I think we can keep the rest of the questions till the end of the talk,
Sure.
just in the interest of time. So please.
Sure. Yeah. No, we're good, I think. Thank you. All right. So let's move on to the last part. This is about still focus on clinician burden, but there's another aspect of inbox messaging, or might have heard of patient portal messaging or secure messaging. These are all different synonyms of the same thing. And these are basically the messages that clinicians get through the patient portals, and patients are asking about their questions, about their information or whatnot. And the there are many studies that highlight that the volume of such messages are increasing, and more so during the pandemic. And this leads to the clinicians spending more and more time inside the electronic health record systems. And there are also studies that highlight that these are not um, entirely done during working hours. So they have to sometimes devote time outside of their working hours to respond to these kinds of queries. So this leads to clinician burden in many ways. In order to tackle this, we curated another data set that we like to call as Archer QA. And the main components of this data set are, you have a patient question. So a patient question may look like, so I took my father to the emergency room and so on, and they conducted a surgery. So why did they do this surgery? Or like after they are discharged, for example, they're asking, why did they perform this particular surgery on the patient? And we have another clinician version of the question in the data, which is a clinician's interpretation of the question. So this is the question that clinicians want to answer for that given patient question. So the clinician's version of the question is, why did they perform emergency salvage repair on him? And essentially, we want to answer this question. And we have associated clinical note excerpts in the dataset. So for this particular question, we have these two paragraphs from their electronic health record note. And each sentence in the note is annotated with one of three labels. So either the sentence is essential in terms of answering a given question. So in this case, the first two sentences are very important when you're answering the provided query from the patient. And the sentence number 8 is supplementary, which means that it can support the answer, but it's not absolutely needed in order to answer that question. And then all the other sentences are not something that is a must when you're replying to the patient about for their question. So the proposed task is to generate an answer that cites back into the clinical note that is provided with the question. So if the patient is asking a question and there's a relevant electronic health record data associated with it, can you generate an answer that appropriately answers the question, but also cites the essential information present in the clinical note? So each instance in our dataset consists of patient question. So you can these are hand curated. They are reflective of the patient portal messages, and you have clinician questions. So these are clinician rewritten versions, and these are the questions that can be used to help them in answering the questions from patients. And the clinical note excerpt is where each sentence in the note is annotated with one of these three labels, where you have either essential sentences that must be used in order to answer the question, supplementary sentences that provides support, but they are not necessary. And then you have all the other sentences which are not relevant in answering the question. We have 130 total cases, and for the development, we providing 20 cases. The other are the test cases that will be released later on. And the data set consists of about 20 sentences per note, out of which about 7 sentences are essential in answering the question. and 2 to 3 sentences are provide supplementary information, and all the others, close to 12 sentences, are not relevant. So this creates a sufficient level of complexity in terms of answering the questions in the dataset. We conducted some baseline experiments using the latest version of Llama, which is 3.370 billion. And the evaluation is performed on 2 aspects. So one is the factuality, and the other one is relevance. So factuality, we can talk about relevance first, because that's what we have been seeing so far with the text comparison metrics. We saw these 3 different metrics before, right? Rouge, Berg score, and Metcon. And in this case, what we do is we compare the generated answer with the essential sentence similarly. And then we included 2 other metrics to account for the different nature of the task, which is the SARI metric. So SARI metric considers the question differently when it is evaluating the answer. So it also considers that the question is taken into account specifically when the model is answering the question. And similarly, the align score is based on whether the answer is using all the facts, or it's basically aligned with the input data that is provided to the model. The factuality scores are basically F1 scores on the citations that are present in the generated answer. So, for example, if the model cited all the essential sentences correctly, they get the best strict F1 score. And there's another version of F1 score, which is called as lenient. So it considers that the supplementary sentences can also be considered as useful answers. So this provides another measure of how well the model does in terms of citing the answers, citing the input data in their answers. So currently we are running a shared task as part of BioNLP at ACL 2025, where this is the proposed task, where we ask the participants to use any of these 3 elements, which is the patient question, clinician question, and the clinical note, and then generate an answer that is grounded in the clinical note that is provided to the model. So in this case, you can say the model should cite which of the generated sentence in their answer correspond to which particular sentence in the clinical note. So they are not generating things in the wild. It can be something that can be verified by the user. And so far, we have released a development dataset, and the test set is going to be released this week. And we will expect the system responses to be due sometime by the end of April, and the papers will be due in May. And more information you can find out by going to the shared task website. And I think at this point, I'm ready to take any other question. It's a big thanks to my mentor at NLM, Dr. Dina Demner-Fushman, and the Intramural Research Program here at the National Library of Medicine, and all the experiments that were performed on the BioWolf cluster provided by NIH High Performance Computing. And that's all from my side. So yeah, happy to take questions.
Thank you so much, Sarvesh. And before we start with the question QA, I would like our audience to thank our speaker for this really nice talk. Okay. So I think we have a couple of questions that we had from section while you were explaining section 2. So I think this question was in relation to what was there presented in your section 2, and the previous question was like
Sure.
what essentially triggers a new progress node generation. So in follow-up to that question, we had another question from the audience, like does this require uniform time steps across patients when generating the next node?
Uniform time steps, as in like you have to have like every 24 hours.
Yeah, let's see.
Uh-huh.
For the same patient,
Mm-hmm.
when you're gonna get his next note, 24
Yeah.
hours or 48 hours, 72 hours, assuming the patient condition may be changed. And the
Right.
patient wants.
Yeah. So for the purpose of these experiments, we usually use the time point of the next node that is available in EHR. And since we focus on the progress notes that are written by physicians, they are usually written once in 24 hours, roughly. So they are not exactly 24 hours, but they are sometime between like 23 hours, 24 hours, 25 hours. So they are like that. But if you go more than 24 hours, you have to include more information between that time frame. That's
So
the
you
only
don't
catch.
have when you don't tell the model time step to generate one. You do not tell the model say to generate next report for 24 hours or 48 hours. So you don't have the time information.
We have the time associated with the actual node, and that's the time we use. But in the real world, you can assign the same time for every day. For example, at 9 a.m. every day, the model will generate a note.
Okay, thank you.
Yeah.
The next question is like, are the locally used models fine-tuned?
No, they are not. We are using just off-the-shelf models for the purposes of these explorations. And yeah, that one of the ideas is to try and use the fine-tuned versions of it. Yeah. The data is available publicly. I mean, it's still in processing, but it will be available soon on PhysioNet. So yeah, people are free to explore the data set as well.
Okay. Are there any more questions from the audience?
I will ask some more specific questions after by email or when available, ask some more specific questions about their work.
Perfect. I think we can put you in touch with the presenter.
I have actually a quick question. Thank you so much for the talk. Interesting stuff. For the manual evaluation, basically anything beyond the automatic metrics, did you use medical professionals to assess the quality of the generated summaries? And if yes, I'm just like wondering what is the scale, like how many people were involved in the manual evaluation of the generated summaries?
No, we did not perform a more like structured evaluation with like recruiting medical professionals. It was performed by me, and it was reviewed by my advisor, who is a physician. But yeah, that is one of the things that we have in mind, which is to actually evaluate these things by clinically, like how clinically relevant are they as viewed by a medical professional.
Thank you.
If there are no more questions, I would again like our audience to ask our audience to extend a round of applause, virtual round of applause for our speaker. And yeah, thank you so much, Sarvesh, for giving this talk. And this talk will be made like available on YouTube. And thank you so much. And if anybody wants to get in touch with the speaker, we will again send out an email with the speaker's details. With that, we would like to end today's MedAI session. Thank you so much for making this so successful.